All right, ready to go deep.
Yeah.
Today, it's all about you, like how your body actually moves.
It's stuff we take for granted every day.
Totally. We're using widc2.pdf. It's from this personal trainer certification program.
Oh, cool.
So think of this as like a crash course in your own anatomy, skeletal stuff, muscles, how you get energy for workouts.
And for everything else, too, of course.
Right. And we'll get into some wild things like, did you know you've got multiple types of muscle fibers?
Most people don't. Or how your body picks its fuel source depends on what you're doing.
Exactly. Okay, got to start with the basics though, right? Bones.
Foundation of it all.
Easy to picture the long ones, like your femur, that's for leg movement and all.
Yeah.
But there's also short bones, all those tiny bits in your wrist.
Intricate, yeah.
Then flat ones, like ribs protecting your organs. And irregular bones, weird shapes like your vertebrae.
Each with their own job to do.
Oh, and don't forget that articular cartilage,
So important. That smooth surface on the bone ends.
where they meet at the joints.
Exactly. It's like the nature's shock absorber, you know?
Without it, ouch, every step would hurt.
Big time. So joints are where the movement happens.
Some don't move at all, right? Like the sutures in your skull.
Right, those are fixed. Some have a little give.
But the stars of the show are the freely movable ones, the synovial joints.
Tons of those. And they're categorized by how they move, too.
Oh, like ball and socket, that's hips and shoulders, big range of motion.
Yep. Then hinge joints, like your elbows, knees.
Like a door opening and closing.
Pretty much, but there's more than those two. Ellipsoidal, saddle, pivot, gliding.
So many ways to move.
That's why we can dance, do sports, all that.
True. But how do we even describe these movements, like, consistently?
We use this thing called the anatomical position.
Anatomical position.
Yeah, imagine standing straight, arms at your sides, palms forward, feet shoulder-width apart.
So that's like our baseline.
Exactly. And from there, we map out movement using 3 planes.
Planes. Like a grid.
Kind of. First, the sagittal plane. Imagine cutting your body in half, left from right.
Down the middle.
Right. Forward and backward movements happen there, like bending over.
Got it.
Then there's a frontal plane, divides you front to back.
So side-to-side movements.
Yep, like raising your arms out to the side.
Okay. What's the last one?
Transverse plane. That's all about rotation, twisting your torso, things like that.
Like a built-in GPS for how our body moves.
I like that. But of course, movement doesn't happen without.
Muscles. The engine.
And they're more than just flexing. They can shorten under tension. That's concentric action, like lifting weights.
Makes sense.
They can lengthen under tension, eccentric action, like lowering the weight slowly.
Oh, so it's not just letting it drop.
Ideally not.
Okay.
And then isometric, where they contract but don't change length.
Holding a plank, that kind of thing.
Exactly. That eccentric action, though, people underestimate it. Important for strength, preventing injuries.
Like running downhill, your muscles are controlling that descent.
Exactly. It's like a braking system.
And then there's ballistic movement, right? Super fast, like throwing a ball.
You got it. Minimal resistance.
So we've got all these different types of movement, but muscles don't work alone, do they?
Nope, it's teamwork. They're grouped together to make things happen at the joint.
Like in our core,
Right.
the axial skeleton, the rectus abdominis,
Six-pack abs.
and the obliques, those are for stability, right?
Core strengths, big time.
And then there's the appendicular skeleton, that's our limbs.
Right, so like shoulders, you've got deltoids, pectoralis major, latissimus dorsi.
Mouthful.
At the elbow, there's the famous biceps and triceps pair.
Classic combo.
And for the hips, you've got gluteus maximus, hamstrings, quads.
All working together for those squats and lunges.
Exactly. Each group has specific actions, too.
Flexion, extension, abduction, all that.
Yep. Flexion is bending the joint. Extension is straightening.
Abduction is moving away from your body's midline. Adduction is bringing it back in.
You got it. It's crazy how coordinated it all is.
So we know the players, how they move, but what about actually putting it all together?
That's where biomechanics comes in. The physics of our bodies.
So cool.
One big thing is stability. How we stay balanced, even with forces acting on us.
Like standing on one leg versus two, way harder on one leg.
Right, your base of support is smaller. That's the area touching the ground.
So our center of gravity, where our weight's balanced, has got to stay within that base.
Or you topple over. And then there's torque.
Oh yeah, I remember that. It's not just about muscle strength.
Nope, it's rotational force. Like using a wrench, farther out you grip, more leverage you've got.
Same with muscles. Their angle matters.
Big time. Affects how much force they can produce.
Like a system of levers and pulleys built right in. So bones, joints, muscles.
Mm-hmm.
We've got the movement part down. But where does the energy come from for all this?
Now that is where things get really interesting.
I'm intrigued. You know I love this stuff.
Our bodies have these awesome energy systems, like a power grid fueling every move.
No way. So there's two main ways we make energy, right? Anaerobic and aerobic.
You got it. Think of anaerobic like that fast charging battery for when you need a burst.
Sprinting, heavy lifting.
Yep. Doesn't need oxygen, so it's instant, but it can't last long.
That's why we got to rest after sprint. Our battery's drained. What about longer efforts, like a long run?
That's where aerobic shines. Uses oxygen to break down fuel steadily. Carbs, fats, even protein.
So it's like a hybrid engine switching between sources.
Pretty much, both systems work together depending on what you're doing.
So our body just knows which one to use.
It's constantly adjusting. Intensity, duration, it all plays a role.
Wow, so smart. And you mentioned this thing called the respiratory exchange ratio, or R.
Ah, yes. That tells us what fuel you're mainly using during exercise. Burning more carbs or more fat.
Makes sense. High intensity, we use more carbs, right?
Yep. Lower intensity, longer time, it shifts towards fat.
So those fat burning zones they talk about, it's all connected.
Exactly. But what's really happening inside when we exercise, how do muscles use that energy?
Yeah, we got to zoom in further.
Down to the microscopic level, muscles are bundles of fibers, and each one has its own, personality.
This is getting deep. I'm loving it.
We'll unpack that next time. Get ready to explore the world of muscle fibers. All right, those muscle fibers, right. Like we were saying, different types.
Yeah, like some are for sprinting, some for marathons. It's wild. We've got multiple kinds.
Each one has its own, I guess you could say, personality and what fuel they like best.
Oh, interesting.
So those fast twitch fibers, type Da's, they're all about power, speed, anaerobic metabolism mainly.
Meaning they don't use oxygen.
Right. Quick bursts, like sprinting, lifting something heavy.
But they tire out fast.
Exactly. Now the type B, fast oxidative glycolytic, bit of a mouthful.
Sure.
They're more of a mix. Can use anaerobic or aerobic metabolism, faster than the slow twitch, but not those pure sprinters.
So like middle distance runners need both speed and endurance?
Yep.
Then you've got the slow twitch, type I. These guys are the endurance kings, mostly aerobic.
Marathoners, they just keep going.
All day long. They're not as fast or strong as the others, but boy, are they fatigue resistant.
So are we stuck with the muscle fiber types we're born with? Or can training change that?
Good question. Genetics plays a part, for sure, but training can influence things.
Really?
Yep. Like endurance training can make some fast twitch fibers act more like the slow twitch.
So even if I'm not a natural marathon runner,
You can still train your muscles to get better at it.
that's encouraging.
It's about optimizing for what you want to do. Now, let's get into how our nervous system plays into all this.
Oh, even more complexity.
Your muscles have these tiny sensors called sensory receptors. They're sending feedback to your brain constantly.
So it's like our muscles are talking to our brain.
In a way, it helps you control movement, avoid injuries. One important sensor is the muscle spindle.
The what now?
Muscle spindle. It detects changes in muscle length and how fast it's changing.
So if a muscle gets stretched too quickly, the spindle's like, whoa, danger, sends a signal to your spinal cord.
And that causes?
A reflex contraction. The muscle tightens up to stop you from overstretching it.
That's wild, like a built-in safety mechanism.
Exactly. Now, when you're lifting weights, a different sensor is important. The Golgi tendon organ, or GTO.
Another one to remember.
It's in your tendons, those cords connecting muscle to bone. The GTO monitors tension.
Tension meaning?
How much force the muscle's exerting. If it gets too high, GTO is like, nope, too much. Signals the spinal cord to ease up the contraction.
So it prevents us from, tearing a muscle or something.
Exactly. Pretty amazing, huh? These receptors play a huge role in strength training and flexibility.
Oh, so?
Well, with strength training, as you lift heavier, these sensors actually adapt.
They get stronger too.
In a way, you can handle more tension, more force.
So it's not just the muscles getting bigger, it's our nervous system learning too.
Totally. And for flexibility, gotta understand that stretch reflex. Yank on a muscle too fast.
It fights back.
Yep. But ease into it slowly, hold the stretch. You can override that reflex, let the muscle lengthen.
So no more bouncing into stretches. Got it.
Yeah.
Man, this is complex stuff, all happening without us even realizing it.
The human body, it's incredible.
So we've got the energy systems, we've got the sensors. But how does all this energy actually make our muscles move? Like on a tiny scale? That's what I'm still wondering. Okay, so we've got these energy systems, right? Anaerobic, aerobic, fueling everything we do. But how do they actually, like, make the muscles move? I'm still kind of mind blown by all this tiny scale stuff going on.
It's wild, isn't it? Well, we got to talk about this little molecule called ATP.
ATP.
Yeah, it's like the energy currency of your cells. Muscles use it for everything, lifting, running, even just breathing.
So ATP is the actual fuel. And we get it from those anaerobic and aerobic systems.
Exactly. Remember, anaerobic's that fast battery. For quick bursts, well, within that, there's two pathways.
Two pathways.
Uh-huh.
Yeah.
First, the ATP PC system.
Yeah.
Super fast, uses stored ATP and creatine phosphate.
So, like, instant energy. First few seconds of max effort.
Yep, that's what gets you off the starting line. But for anything longer,
We need something more.
right, that's where the glycolytic system comes in. Uses glucose, a type of sugar, to make ATP.
So, a bit longer lasting, but
It produces lactic acid. That's the burn you feel when you push hard.
the good old burn. And then for the real long haul.
We've got the aerobic system, our hybrid engine, uses carbs, fats, even protein if needed.
Needs oxygen, though.
Right, so it's slower to start up, but it can just keep going and going.
Marathon fuel. So our body's always switching between these, depending on what we're doing.
Exactly, like super smart energy management going on, intensity, duration, it all factors in.
Amazing. Okay, back to the muscles, though. How does ATP actually make them contract?
All right, so inside each muscle fiber, you've got these protein filaments, actin and myosin.
Tiny little proteins.
Tiny, imagine like two rows of people facing each other, holding onto a rope.
Okay, I'm picturing it.
When ATP is there, the myosin grabs the actin and pulls, making the muscle shorten.
A microscopic tug of war.
That's a great way to put it. And ATP is what provides the energy for each tug.
Wow. No ATP, no muscle movement.
Pretty much. We've gone from bones and muscles all the way down to these tiny molecules.
I know, it's incredible. My mind is officially blown.
But it's all connected, right?
Yeah. So, big picture, why does all this matter to, the average person?
Because understanding how your body works, how it moves, how it uses energy, that's how you get the most out of it.
Makes sense.
Whether you're an athlete or just trying to stay healthy, this knowledge helps you choose the right exercises, avoid injuries.
Like having the owner's manual for your body.
Exactly. Move better, feel better, all thanks to understanding what's going on under the hood.
Well said. This has been an awesome deep dive. Thanks for joining us. We'll see you next time for more anatomy adventures.